All right, well, hello everybody, and welcome to today's webinar, Collaborating, Exploring Virtual Manipulatives, and Deepening the Conceptual of Factors and More in a Distance Learning Classroom. Our presenter today is Rebecca Strom, and she's with the Atlas's Minnesota Numeracy Initiative Advisory Team. Please welcome her by saying hello in the chat box. Let us know where you're calling in from today. And if you have questions during the course of her presentation, you can go ahead and submit those into the Q&A box. And with that, I'll turn it over to Rebecca. Thank you.
Thank you very much. Appreciate it. Welcome, everyone. My name is Rebecca Strom, and I am teaching in southern Minnesota here in the cold. And I appreciate, I'm going to monitor your chat the best I can, so keep them coming. It's great to see you. This session was originally built as an interactive, like breakout rooms, kind of a thing of exploring ideas. Obviously, we can't do that in this setting, but we will do the best we can. So I'm going to try to utilize the chat box as much as we can. So don't hesitate to reach out and ask questions. I will try to keep my eye on it the best I can. So today's session is collaborating and exploring virtual manipulatives, deepening conceptual understanding on factors, and then thinking about how that looks in the distance learning classroom. We're going to explore what it means to, what does multiplication and division mean? We're going to try to connect those ideas to factors, prime numbers, and composite numbers, and then looking at how that can also connect to square roots. And the main idea is that we're looking at this idea of virtual manipulatives. So we're working on building that conceptual understanding, but also that coherence across the levels. So as we're doing this, we want to keep our minds on the math practices. So today we're kind of in the learner's shoes a little bit, looking at things of how our students would react to them, asking questions if we can, and thinking about, are we making sense of problems and persevering? Are we looking for patterns and constructing viable arguments? All the things we want our students to do, are we to build that deeper understanding? So I've been teaching math on and off for about 25 years, and I've been in adult education now for about 15. And ever since being in adult education, I started having students ask questions that I realized I don't really have all the answers to, and I need to dig in deeper. Those memory work steps just weren't cutting it anymore. We want to look and deepen understanding. Yes, Terry, great question. At the end of this session, I'm going to drop a link for a handout, and the handout will have links for you to create. It'll force you to create copies of the Jamboard I'm doing today, the PowerPoint. If I'm using it, it'll be in there, so you'll have access to your own copies of everything. So this idea of levels of knowing, if you're not familiar with Sharma's levels of knowing, it's this really rich experience of learning math, starting with the intuitive level. What do our students already know that we can connect to? Concrete, that they are moving and touching and working with manipulatives. Then the representational, the pictorial, can they draw what they're doing? Can they represent things? The abstract is that level of the symbols, the algorithms, copying and writing and the carrying and the drawing things out. Application, can they use what they learned today and apply it in a very real life situation? And then communication is, can they explain their thinking to someone else? That communication level being the highest level of understanding. In the NCTM, the National Council for Teachers of Mathematics, they focus on it called the CRA, that concrete before the representational and then the abstract. And as many as you remember, we typically learned this straight abstract. We didn't really have those opportunities for concrete and manipulatives and things like that. So we want to kind of back up a little bit and dig in so our students can deepen their learning. Excuse me. So today we're going to touch on three standards. We're not going to dig into the whole depth of the standard, but these are the three that we're going to focus on connecting. There's a level B standard that talks about products of whole numbers being multiplication, that we're looking at things as equal groups. The level C standard that talks about seeing a number and being able to identify its factors and know if it's prime or composite. And then the level D standard, looking at square roots and evaluating square roots of numbers. So even though these are all completely different levels, we're going to use the same manipulatives to connect them so that students, when they come back, they have this something familiar to work with. So when we went from in-person to online learning, I have an iPad, so I was able to draw on my board and we shared it on the screen. And I realized that we had gone from this classroom of hands-on learning to traditional, I write, you copy. And I thought this isn't what we want to do. So how can I get back to focusing on levels of knowing, rigor, and the math practices and build that coherence, but now in this online setting? So one of the things I explored was online virtual manipulatives and online things. And there's a lot of great resources out there for virtual manipulatives. But the one thing I was looking for was a place that students could work together. And if they would often both log into the same website for these virtual manipulatives, they were working very independently. So then I started exploring Jamboard more. So just of a quick poll, how many of you use Jamboard or have used Jamboard or have not heard of Jamboard? What are your personal experiences with using Jamboard? It is part of Google Suite, so you might have it using it in your classroom. All right, I'm seeing a lot of nope, yes, perfect, love it. All right, so I'm gonna do a quick, just basic overview of it. Have some that have said never heard of it, never used it. Okay, so I have become in love with Jamboard. I use it pretty much every day now. So Jamboard is part of Google Suites. When you get the link, you'll be able to open a Jamboard. You can create your own. It's intended to be a virtual whiteboard. So you can draw on it, you can write in it, and there's sticky notes, but I've kind of like taken it and turned all my sticky notes into this idea of a virtual manipulative. There are some pros and cons to Jamboard. The pros are students can work on the same page synchronously or asynchronously, but also work together. So I have students who are in person and I have some online. They can open a Jamboard, they can write on the same page, they can talk, they can work things out together. They're able to import pictures, draw shapes, type boxes, move things around. So it's a really nice interactive place. It's free, it's online. There are free apps, so students can download them on their tablets, on their phones. I prefer the computer because of bigger screen, but it is very easily very accessible. And the main, of course, thing is that students can work together. So great question about the Jamboard and the Zoom. So we'll play with this and then you'll let me know at the end if you see any perks. The nice thing about the Jamboard whiteboard is students have access to it even when they're not in a call. So it's permanently in, once they've opened it, they have access to it and they can keep working. Jamboard is limited to 20 people at a time in a board. And it's also limited to 20 pages. So sometimes for presentations, I've just made multiple Jamboards. If you have a really big class, you could make multiple Jamboards as well. Quick question, Jamboard to have a coordinate plane that we can write on. Yes, you can import a background of a coordinate, any PDF, any picture or PDF, you can import as a background and then write on them. So yeah, you could easily do coordinate planes. Okay, so the cons are working on your tablet and your phone. Keep the questions coming, they're great. But the screen is really small, so that makes it incredibly challenging. If you're in a Google Meet or a Zoom and then you transition students to Jamboard, sometimes you have to say, go ahead and come back to the Zoom so we can talk again. There's a little bit of clunkiness, but it has been incredibly helpful. When you're in Jamboard, you have some tools. So these are the super light basics. The ones that we're going to use the most are the pen if you want to draw. There's a select button or an arrow that you click on so that you can move things around. The sticky notes is one to write things on, or you can just simply create text box to write on the page. So there are other features, but we're just going to keep it crazy simple today as we work through. If you're looking on the desktop computer or laptop versus through the app, there are two slightly different views. So the one on the left is what we just showed about the desktop or the laptop, the web version, I should say. The one on the right is the app view. You may have a little more clicking to do, but you still have the pen. You can still change colors. You can still create sticky notes. So all of the things are there. You do have to click on the little pencil in the corner before you're allowed to edit things. So there's that as well. All right, one more thing I really like about Jamboards are at the top of the page, you can see your screen, and if you click on it, you can see multiple pages that you have in that particular Jamboard, and you can see which students are working on which page. So sometimes it's been a student as, I don't understand what you mean, and then I'll look and say, oh, well, it looks like you're on page 4 and we're on page 6. So it's a really nice way to see where students are. It's not like Google Docs where it saves who wrote everything, so that part doesn't track people's work in the same way. But you can, there are other ways that you can talk to your students to have them communicate. All right, so that is a crazy overview of Jamboard. I just wanted to talk about it before we jumped in, but we're gonna play with some of the tools. Are there any other question? You like the anonymity because it reduces pressure? Yeah, it can. So for me, we're in Google Classroom when they open the link, and so I can see their actual faces of who's on each page. If you're not logged in, it will just be just like Google Doc, you know, anonymous animals. And so there are both sides. So let's look at a sample of my Jamboard. I'm gonna quick grab this. All right. So this is the Jamboard that you're gonna get a copy of. And we're just gonna walk through the first couple of pages. Once again, I put in there a hint of the tools if this is a newer experience for you, just the ones that we're using, but there are lots more. Like I said, I tried to keep it simple for my students. Sometimes too many bells and whistles can get really distracting. I also have a page with the math practices in here because today we're looking at this from a learner's perspective, and how are we challenging ourselves to reason and critique and model and do all the things we want our students to do. All right, so let's start with this one. This is something like these activities I have done with all of my students. So what does it mean to multiply? So often when I ask my students this, their first answer is, what do you predict? Let me ask you, what do you think your first answer is going to be when we ask our students, what does it mean to multiply? Yes, you can use it with ESL students. Most of my students right now are GED or ESL. Absolutely, the answer is times. People say, oh, it means times. And then I ask them, what does times mean? And they say, I'm not sure. So exactly, so they say they don't know. All right, it says my screen is paused and I'm not sure why. Let me apologize, let me resume share on that one. All right, thank you. Okay, so they say they don't know, they're not sure. And so I try to say, let's talk about what this means, but let's not use words that aren't defining what's happening. So I created this Jamboard and I made a stack of sticky notes on the corner. So this stack of sticky notes, they all have periods on them because you can't make a blank sticky note. So when I click over here, I'm able to write a sticky note. I can type whatever I want. You can change the color. So I pre-created a stack on the corner and I asked them to use those to demonstrate what 4 times 5 means. And so this is something I have done in my class. I liked those plastic square tiles. I use them for a lot of different things in math. So I was trying to recreate that feeling of the square tile. So giving those, then you can drag the sticky note over and create this idea of doing it. Yes, I'm seeing some great definitions. A quicker way to add the same number over and over. You've got words like product, adding in multiples. Exactly. So as we're doing this, what would you predict you could do with these squares to demonstrate 4 times 5? Make an array, absolutely. There's grouping. So here's an example of what students have done. So they could make an array. We've got 4 rows of 5, or we could make grouping 5 groups of 4 or 4 groups of 5. And we're seeing this repetition of equal groups. So then we keep moving and we look at the number line as well, because we always want to connect the number line to our groups so that when they get to things like coordinate plane graphing, that number line is super comfortable. This is a great way to see, both of these are great ways to show that multiplication is simply repetitive addition of the same thing, or we're focusing on equal groups and then considering how much are in all my groups together. So as they're playing, we're just kind of laying some groundwork that we're looking at these equal groups, multiplication. It can be equal jumps on the number line. There's always more than one way to represent something. So then we kept looking and say, okay, how can you use that to think about division? So how would you think students would be using this idea? How can we demonstrate with all these sticky notes, 21 divided by 3? If I grabbed 21 of these sticky notes, what could I do? I see grouping again. Absolutely. So we're going to put them into 2 ways. We could either consider into 3 groups. I like that answer as well, or groups of size 3. Once again, we can also do an array and a different way of looking at it. So these are some examples of student work again. We've got these 21. We can put them into 3 equal groups. We can put them in groups of size 3. The array where we're looking at each column is a group of size 3, so it's a different way of looking at the same thing. Once again, we can use this so they can draw, they can manipulate, they can move. We've got the idea of a number line where we've got 21 things and we can work backwards by subtracting 3 over and over again. If multiplication is repetitive addition, then it helps us build that connection to division as repetitive subtraction, which feels like a weird thing until I remind my students, if you're standing at the front and you're passing out papers to everyone, you're really subtracting them off your pile until you run out. So this idea of finding these connections, or once again, on the number line, we can actually draw 21 things, chop it into 3 groups and count how much is in each group. So then this conversation happens about what are some connections you see between multiplication and division? So what would you, looking at those past pages, what did you notice? So we did some number lines, we did some groups and arrays. So when we put them side by side, what do you notice about the patterns on the left and the patterns on the right? Right, we're grouping and ungrouping. And so the idea, I've actually had students go, well, that was kind of like what we just did. And it was really awesome that the student realized that multiplication and division, these properties are so connected. And we talk about inverse operations, and one's putting them in groups and one's taking them out groups, but the conceptual understanding of them is the same. So as we're moving, the number lines, like I said, I just found a graphic you can import or you can write right on the screen. So there's a lot of really awesome ways about this. And I really wish I could just put you in a breakout room to play with them, but I promise you'll get one at the end. So don't hesitate, keep asking all the questions. So let's keep playing. So now we're really deepening this understanding of multiplication and division. It's about putting things in groups or taking things out of groups. We're looking at totals. We're looking at how many groups. Sometimes we're counting size of groups. Sometimes we're counting how many groups there are. There's just this really strong connection between these operations. So then we're going to keep playing with numbers. So how would you say if you were given this? Your task is to take 10 of these squares and put them in groups of 4. So what would you expect to happen on this one? Absolutely. Oh, I like everyone saying leftovers. That's great. There's going to be a problem, isn't there? It doesn't make equal groups very well. So I can grab my pen and I can say, well, if I want groups of 4, here's a group of 4. Here's a group of 4. And I don't have another group of 4. So that's not going to work. If my task is to create groups of 4, I have this leftover. So maybe I don't want to do that. So I'm going to erase and undo. What if I said we can also divide into 4 equal groups? Well, I'm going to cut this in half. And I'm going to cut this in half. And the groups are equal, but we're not dealing with whole numbers anymore. We're dealing with these partial pieces. So that's not great either. So we're just kind of learning what could you say about 10 divided by 4? If we haven't talked about fractions or decimals, what could you say? I see there's not enough numbers, there's leftovers, there's a remainder. There's 2 groups of 2, but there's leftover stickies. Yeah, the problem is it doesn't work out great. So there isn't a great way to do this. If we wanted the rectangular array, I'm going to switch over and say, if I wanted to make rows of 4, because my task is to divide by 4, there just isn't complete. So this kind of starts a what do you notice, what do you wonder thing. Once again, I could draw on a number line with my pen and move things, but what do you notice about this? This kind of leads to a conversation about what are we connecting this idea to? Just check in the chat. Remainders, fractions, absolutely. So we're looking at this idea of divisibility and factors. Yes, remainders, fractions, division, all of these great conversations are going to happen. So let's keep this on hold for a minute. Yep, you've got a great real life situation. We've got cupcakes and children and we want to share, but let's pretend we can't cut them apart because it would be a mess, right? We're not ready to deal with fractions at this point. So let's keep peeking ahead. So this activity is one that I actually really like. I would literally give out those 24 tiles and I would give them to each pair of students. And the task was create as many rectangles, which we know is really a rectangular array, but for the students, as many rectangles as you can and record the dimensions. So if I gave you 24 squares and your task is to create as many rectangles as possible, what would you think that they're going to find? What are some examples you might see? So yeah, right. We want to, and I should clarify that. Great question. Every rectangle needs to use all 24 squares. So as we're doing, I can grab sticky notes, I can write in here. So I see somebody mention a 2 by a 12, and then I see a 3 by 8. I see somebody mentioned a 4 by 6. And anything else that you might notice? 1 by 24. Which one of these do you think is the most commonly missed one? Students often miss the 1 by 24, absolutely, because that long skinny row doesn't work. So now that we've built every possible arrangement that they found, then we start asking questions. Did anybody make a rectangle where they had side of length 5? So we could say, what if I said I'm determined to have 1, 2, 3, 4, 5 things in my side? Can I make a rectangle of side length 5? It didn't work. I have to always use all of them. I can't use anything extra or leave anything off. So if I have 24 things, I'm not able to make groups of 5 without a remainder or a fractional piece left over. So now we're going to start talking about this idea of factors. So how could you connect what we're doing to the idea of factors? So kind of looking at this and the other pages about putting things in equal groups, I'm going to watch the chat for a minute. Go ahead and type in how this idea and the idea of factors work together. Just going to make sure I'm scrolling so I'm not missing anything. I see that factors are numbers that fit into another number. So could you, what do you mean if I had a student that asked about fit? Okay, what could that, has there another way we can say that? Each length and width represent a factor. Factors are the sides, prime and composite numbers. So we're gonna really start branching out. Just by simply playing with these sticky notes, we're really opening up our vocabulary. They can actually see that making an even figure helps you see how multiplication works. Absolutely. So factors, I often hear a lot of variety of definitions of factors, and I'm just going to use my favorite one because I often hear factors are when you multiply two numbers together. And in my opinion, that doesn't really answer a lot of questions. You can multiply a lot of things together. But if we think about a factor of a number is a number that divides in with no remainder. I can make an equal group of that size and there won't be anything left over. We're able to see, like somebody mentioned in the chat box, it could be your column or your length or your width in this rectangular array. If we're able to make equal sized groups, any of these are factors are the length and the width. All right. So factors build numbers, absolutely. They're kind of the building blocks of our numbers. We're making bigger numbers by arranging equal groups. So this was something that really, I like the number 24 because it has so many factors. 1, 2, 3, 4, 6, 8, 12, 24. It really does help with a lot of play. There's a lot of time to play and explore. So we play with that for a little bit. And then of course that leads to more questions. And so this is the next activity. Let's do the exact same thing, but now I give students 13 squares. So what would you notice about this activity? This helps students see factors pair rather than just factors of a number. That's true, because a factor has to be is always multiplied by something. I'm just going to scroll through and catch all the things. Numbers represent different lengths and width. They actually help make even figures. I did see a question in there about how to do this with down to prime factorization. I have not explored that yet. I wonder if we would just keep breaking things down, but I think that it challenges me to think a little bit more. So on this one, absolutely, I'm seeing a lot of only one set. So if I have 13 things and I try to make groups of 2, it's not going to work. If I try, a row of 2, it won't work. If I tried a row of 3, that's not going to work either because there's always going to be something. And it's nice to say, try side 2, try a side of 3, try a side of 4. And they literally are able to physically try every possible number smaller than 13. And then the conversations kind of start happening that there are some numbers that the only rectangle you can make is one long, skinny rectangle. And so then, of course, some of you have already mentioned, what is it called if you can't break it down into any other numbers? I think I saw people scrolling through already. There's the idea of prime numbers. So a prime number, often once again, that falls under that amazing memory work section. We have to memorize prime numbers. What is prime? I'm not sure, it's just that number. But that it is a number that can't be broken into equal groups. The only group you can put it into is one big group of it or groups of size 1. And so having that opportunity to play and explore, and that the evidence is there, they cannot make anything of size 2, size 3, size 4. They can make rectangles, they could make piles. They're able to continually represent and, we're able to represent their thinking by writing things in here. So I could do a length of 1 times 13. Or of course, somebody might say I did 13 times 1, and that also brings up more conversations. So what would you say about this idea? Well, if somebody did 1 long rectangle up and down, and someone did 1 long rectangle left and right, what conversation would come out of that? What would that connect to?
I found this on the web.
Siri's trying to answer my question. So a great question, there's a question in the chat. Do you call on one student at a time or move the squares, or do they each have their own? So on an activity like this, I would create 1 page for each pair or group of students so that they would be working together. So I would say, like where my pink sticky note says, what does it mean to divide? I might take another one that says group 1, group 2, group 3. Another point I like about Jamboard is, oops, let me cancel that, sorry. When you are in creating a sticky note, for our students can create one, you can choose a color. So I will often tell students, grab a sticky note and put your name on it in a particular color. And then from there on, all of your questions can be that same color, and we'll know who's asking which question. And if you have different students, one can pick blue and one can pick orange. And that way, if there are questions or they're showing their work or they're adding their own thinking in their comments, we're able to see whose work is whose. I have put a student, yeah, that's another idea. I have put students' names on slides lately. With the COVID going on right now, our class sizes are pretty small, so I just kind of randomly put them in. Sometimes they just work together. For those who are challenging using the mouse to draw, you can pick up a digital pen. Absolutely. So when I do this, I have my iPad. And what's great is if when you're teaching, you can have your iPad open to Jamboard and my computer's open, and I don't even have to have them connected. I can write without bringing my iPad into the Google Meet, because as opening multiple wings, you can still work and collaborate. So that's been really nice. I have the pen, which is much nicer to work with than this mouse right now. All right, commutative property is exactly what we're looking for. This idea of 1 times 13, 13 times 1, even on the other rectangles, someone else may have written them in opposite rows, and it brings in this idea of your rectangle and their rectangle is simply turned. It still has the same number of pieces. We still have the same rows and columns. They're just turned over. So it might be a different length and width, but we're still working on this exact same idea and the same thinking. So once again, this talks about prime numbers. It introduces it, but we're pulling in that vocabulary check-in. What does it mean to be a factor? I can put things into equal groups without anything left over. So let's keep playing with this idea. So then we're going to talk about, if we talk about prime numbers, then of course we want that mathematical vocabulary. So what is a composite number? So this is an opportunity for students. We've never explicitly explained it yet, but what do students think? Can you talk together and decide your own? If we know what a prime is, can you describe what a composite number is? So this is a quick one where these numbers are part of the screen. You can't move them, but these are movable. And so students would talk as a pair, determine which one are prime, which one are composite, move them into the appropriate column, but also grab a sticky note to define how they think of those two words. There's always a pile of, for this particular Jamboard, what was really nice is I made a big pile of sticky notes and then you just duplicate that page. And then sometimes they're on pages I don't need them for, but I didn't want to delete them. But that way they're always there for students to play with and they're in the corner. Is it hard to get the right dimensions on the picture you use for the background? Sometimes it is, for sure. And it takes a little bit of practice. Sometimes I'll put a picture on, you can either place a picture on top or you can embed it as a background. When you embed it as a background, it's a little trickier to get the right dimensions. So my new trick has been put a graphic on top of it just as a picture. The downside, it's movable, but then I'll snip that page and then use that as a backdrop, import it, because it's nice when students can't accidentally delete the part you want them to work on. So yeah, now my computer's full of snips of redoing things, but it's worked awesome to like get it set exactly the way I want, put random pictures wherever I need them, and then just take a shot of it. Yeah, I've been kind of playing with Jamboard a lot since COVID hit because I love this idea of a virtual manipulative, and I want them, but for me, it's crazy important that they're able to collaborate. Can you talk to your neighbor? Sometimes if numbers are low, I'm their neighbor and we talk through things, but I want them to have that conversation because if they can get to that highest level of understanding by explaining their thinking, sometimes, as you know, ourselves included, we'll, no, this is what you do. And halfway through you go, never mind, now I get where I'm wrong, because you have to have those moments of talking and thinking. All right, so let's keep going. I have just a couple activities left. So the next one is, okay, now that you think you can define prime and composite numbers, let's play a little bit more. So on the next page, I created this page, and these are all just sticky notes that they can move. So they were to work in groups and work with a partner and determine which numbers are prime and which are composite. And if you think it's prime, all you have to do is edit the sticky note and turn it pink. And if you think it's not, you can leave it yellow. You can make backgrounds in Google Slides. Yeah. So there's a lot of great ways to get this really cool backgrounds of whatever you need. It's super flexible, super open. So on this one, like I said, this was a great activity that I let students do. I had a really low number the day I tried this for the first time. So one of the tricks I did was to mute myself so that they knew I couldn't interrupt when they got stuck. So they could see the little mute mark on my camera so that they knew I wouldn't, because as a teacher, it's so tempting to accidentally like interject when you don't want to. So muting myself was actually really helpful for me as well. So I muted myself and I just sat there and listened. And as much as I wanted to say nothing, I did start typing a little bit. But before I did, do you notice that the number 1 I left green? Because that's that random number, not random, excuse me, but it's the number that falls into the neither prime nor composite category. So I kind of wanted to highlight that this one doesn't count. It's not prime, it's not composite. It's kind of its own thing without ignoring that. So that was why the number 1 was green. And then I had students talking and I was listening and they were changing colors, but I decided to capture what they were saying. So while they were talking, I would click on the sticky notes. I had different groups working on different pages. Yeah, this day was a really small group, so I only had enough for 1 page, but I have duplicated pages and each group would work on their own. And if you have a big group, you can put them in breakout rooms and let them work together so that they are able to talk without interrupting each other's thinking, which is great. So as we're working through this page, I could hear them say things like, well, 4 is composite because we know it's 1 times 4 and 2 times 2. So for that reason, I decided to edit the box and list what they were saying. So they were just saying words like, they were just changing colors, and the yellow they weren't changing, but I decided to kind of sneak in there and kind of gather their thinking. So that there was I was writing the evidence that they were talking about. So when they were done, they didn't, we didn't write all of them because sometimes they just said, oh, I know 20 is composite. But I really appreciated that with me muted, I was able to just listen and then kind of help just write their notes that they were talking about so that they would have evidence of why they chose that later. So this was zero help from me. But it was just a really interesting activity for students to work with. Once again, these are those discussions that we usually inform them. I've given out years in the past. Here is a print off of all prime numbers less than 100, and it was just numbers 1 through 100, and the prime were a different color. But this time I thought, let's let them appreciate and dig in so that they understand what that is. And now moving forward, the handout with the different colored prime is really handy, but until they dig in, that's just more memory work of things that they aren't able to really house the information for. So then of course, if we're gonna talk about prime and composite, then we wanted to play a little bit more. So how does this connect to being a perfect square? So let's try something like the top one. Square root of 9. So this was a moment one day when I was teaching several years ago in adult education, and we were talking about, I was trying to embrace this new idea of manipulatives in the classroom, and we were arranging things into squares. And this is those sad moments that teaching math for a million years, going to college for math, still didn't really visualize math as clearly as I should have. But this idea of, is 9 a perfect square? If we have 9 things, are we able to arrange them into a square? So we were talking about this, and it was one of those like crazy moments where I literally am like, oh my gosh, a perfect square makes a square. Like, how did I not ever see that before? But when I was in school, the perfect square was just simply a terminology. It wasn't this idea of it being a square. So the cool thing is now I can say, well, look, we can make a square, and the square root would be what? Somebody want to define how you would describe the square root of 9 using the ideas in these squares that we're looking at. Right. So the idea could be, is like, if you have 9 things, can you make it into a square? And the square root is literally the length of the side. So when we're looking at something like 9, we have memorized and we know that square root of 9 is 3. But what happens when we're dealing with something that's not a perfect square? So we have something like 12. So I can't arrange it into a square at all, but I can arrange it into a rectangle. But seeing that I have this perfect square of 3 by 3 and there's 3 left over gives me the ability to estimate the square root of 12. Now I come from that background of memory work and calculators, right? To me, it was either a perfect square or it wasn't. It never occurred to me to estimate my non-perfect squares. So if I'm looking at this, I actually can consider what's missing. So I need 1, 2, 3, 4 more pieces to make this a perfect square, don't I? So could you estimate what you think the square root of 12 might be? Exactly, just under 3.5. If I have 4 more pieces, then I would have a square root of 16, but there's more than, I'm missing more pieces left. So having the ability to estimate non-perfect squares was really a powerful lesson for myself as well. Because like I said, we came from the world of it's either a perfect square or we left it. I mean, we simplified it, but it wasn't, but it never occurred to me at the time that I could estimate these answers. So this was a way to take these random perfect squares that are irrational numbers, but at least visualize them and then be able to estimate, predict answers, justify my work. Sometimes you do a problem with a non-perfect square and you're asking yourself, am I close? And I would have no idea. So then, you know, I would grab a calculator. This would be great for Pythagorean theorem as well. Absolutely. Yeah, I love Pythagorean's theorem. When I was in class, we would use graph paper, or I would literally pass out these same plastic tiles and we would make a square with the length of one side, make the square of the length of the other side, then grab them all to play with the idea that that would fit a perfect square with the length of the hypotenuse. So there was we were able to play with those in person as well. And so I'm challenging myself that if in person worked with manipulatives, we can find ways to do it, virtual manipulatives and even in Jamboard is my goal. Like showing 12 doesn't make a square. But I could see a student asking why you can't just pull out the square root of 3. True. That could be a little bit confusing, but then, and so that just brings more deep conversation about factors, right? We we can't separate perfect squares by addition. We can only separate them by multiplication. So one more, like these questions our students asking are great because they show that they're thinking and learning and trying. All right, so then my last the activity I did after we played with perfect squares was very similar to the previous one. And it's the idea of giving them this page, having them sit down, talking with a partner. They can go back to other pages. They have a pile of squares on the other pages so they can see if they can arrange them. They can start playing with numbers. It gives them the ability to estimate and predict our answers. So if these are perfect squares, go ahead and change the color. And if they're not, leave them yellow, but then be prepared to explain your thinking. Like, why did you change that color? Why did you not change this color? Once again, I like the Jamboard. If you have a big class, the breakout rooms work really well with, they're actually able to have that conversation and they're on the same page and they can literally almost fight over squares accidentally, but they're able to move the same pieces in a similar way of sitting at the same table and moving manipulatives around. So any questions? I kind of went through this so quickly because this was designed, like I said, the last time I did this session, we were able to put people in breakout rooms so they could play with some things. Are there any questions that you have about these activities or Jamboard itself? So all of this is done in Google Classroom. It can be done in Google Classroom. For my ABE classes, I use Google Classroom. So you can actually upload these right into Google Classroom as an assignment. Otherwise, you can also just send out links. So it does not have to be done in Google Classroom. If you want students to have their own Jamboard, you can post it in Google Classroom with that setting that when they open, it makes a copy so that everyone has their own. I've known teachers where every student gets their own Jamboard and then you can see them because they submit them and you can correct their work that way as well. I know nothing about things being compatible with Microsoft Canvas. Sorry about that. That's because this year we are working in Google Classroom and using Google Suites. I am using this the most. Absolutely. Yeah, like they said, I agree. Brian, Jamboard's not platform. You don't have to do anything. I can just create one like I am right now and share it with you and you could be all in the same. Well, you can because Jamboard has a limitation of 20 people at a time and that's it. But I've presented these conferences where with smaller numbers, I would just create like 6 different Jamboards and drop links and then people could join them and get up to 20 in each one. So you can work together still. So it's nice that it's not connected or not dependent on it. So as we're looking through, like I said, I'm going to peek up here. You can see if I go up here, the different pages that we've looked at. It's this idea of building coherence, connecting the same type of idea, using the same manipulative for a level A or B activity. We looked at B, we looked at C, we looked at D, and we're using the same idea of a virtual manipulative. And so I like the idea that students are familiar with a tool and that they're able to keep using that tool. And like I said, I have students in person. So we open a laptop and they're able to get in Google Classroom. And even though they're in the same room until things are less social distancing, they're still able to talk and work independently or work together as a pair. As I created this session a little bit ago. Originally, I started working with a Google Slides. So the same thing can be done with Google Slides. It's not near as clean because I'm going to have an example here. You can't draw on it in the same way. I'm also dropping a link for this, where if you are a person who prefers Google Slides, what's nice about this is if students are logged in, you can track their work a little bit. They can write their names on them. I was also able to create a stack of sticky notes in the corner. You can duplicate these pages. So this idea of using a virtual manipulative doesn't have to be limited to Jamboard, but I was looking for resources that are free to most teachers and ways that we can edit and move and play with them. But my goal was first and foremost, ways to build conceptual understanding so that we're not going back to memorize these procedures and hope that you hang on to them for the test. So for my in-person classes, yes, we have access. We have a laptop, the cow computer on wheels, so many students, or we also have computers around the room that they can use. Yeah, I have not used Nearpod yet, but I've heard good things about it. And I haven't used a Padlet as an instructional tool, but I am familiar with Padlet as well. Any questions on any? I know I kind of went through this really fast. I just wanted to make sure that we got through all the pages and that we had questions. Like I said, I'm going to drop this. You're going to get a handout that's going to have all the links that are going to be forced copies, so that when you open them, it'll have you, do you want to make a copy? Then you can edit, change, and update all of them. It is a copy of this, so my writing might be on it from the session, but you can simply just erase that and keep going and continue to play with this idea of a virtual manipulative. I'm just going to go to the end. One more quick thing I wanted to, it looks like we have a few more minutes. I was worried we'd run out of time. We still have a couple minutes. So does anyone have any other questions? Yeah, my goal was less is more. So like there are so many more features in Jamboard that you can use, embedding pictures and all of that. But I have learned that embedding the background is relatively new. You can do it from the web version, but you can't do it from the app version, like on my iPad. So there is that. So yeah, the blank stickies are great. Just a reminder, I don't know if I mentioned this before, you can't make a totally blank one, so I always have to put a dot on them so that they work. I also want to just promote for a minute the Adult Numeracy Network. For those of you, if you haven't heard of the Adult Numeracy Network, it's an amazing community of teachers who all teach in the adult basic education world, building curriculum, finding resources, sharing ideas. If you're not a member, I hope you think about being one. There's a link to it on the handout that you will get at the end, and just want to really promote that. All right, I'm going to go ahead and grab that link and drop that for you. I'm going to make sure I have the right one, and I'll just keep checking the handout. So here is the link for the handout. I believe you'll probably get it as a follow-up email as well if you don't see it now. And then I also, just for fun, fun for me, have a link for it'll be in the handout as well, just a Google form to like what would be helpful, oops, I guess that link didn't come up before. Let me grab that. Let me try the link again. There we go. So if I believe you'll get the link for a handout as a follow-up email as well. But then also just a follow-up question about, for Google form, like what helped, what didn't help, what would be more clear in the future? Are there still questions? My email is in the handout. So if you have any questions, don't hesitate to reach out. I think I just dropped it in, but I can drop it again. So this should be a link for the handout. And the handout is a PDF, but it's full of links. So it's got the presentation, a copy of the Jamboard, the Google Slides version of the Jamboard, and then other resources, math practices, CCRS, a link to an Adult Numeracy Network. Atlas is our Minnesota adult education teaching and learning advancement system. They have also amazing resources. So I also put that in there as well. So I dropped the link in this chat box. There's also a poll that'll pop up on your screen right now. Mine just popped up. If you can't see the link, I dropped it in the chat, but I can certainly drop it again. Is anyone getting the link? Let me try one more time. All right, maybe I didn't click on the right thing. All right, I just now dropped it. Hopefully, I think I accidentally put it not to everyone before. Still not seeing it. All right. Nope, not seeing it. Well, that's a great question. Let me see. It says, oh, it keeps defaulting to not be to everyone. Now it says specifically it's to everyone. I copied and pasted it. I apologize. I thought I changed it to everyone, but it looks like it didn't. I'm going to stop share. If you have any questions, like I said, please don't, my email's on there. Don't hesitate to reach out. I still am learning a lot and appreciate all the things people share. Here's also that link for that Google form. It's also in the handout. So I appreciate any feedback that you have. And then, like I said, there was a pop-up window for a quick one question comment from Coabe. You need access. Boy. Hopefully the link will work now. Oh wait, that's the wrong one. Shoot. So the last one apparently I just did was my personal handout, unfortunately. So let me try that one more time. That one should be the right one. So I believe I uploaded the handout before the session started. So she said it would come out with a follow-up and probably the CEU for attending. So if you don't get, for any reason, I'm going to drop my email in the chat box. If for some reason you don't get a handout or the information, just email me and hopefully it'll come along. But it should be there with the handout.
Rebecca, thank you so much. That was an awesome presentation. The handouts definitely will be posted to coabe.org within 24 hours of the completion of this. So yeah, the link and the handouts will all be posted for everybody to retrieve there as well. Thank you again. That was an awesome presentation. I want to thank everybody for joining us today. I hope everybody has a great rest of their day, and I hope everybody has a great weekend. All right.
Have a great weekend, guys. Thank you.
Thank you.